Hey, it's Michael here from EduKits. Today I am going to show you how you can create this cool LED chase effect within CodeKit. And specifically, we're going to be doing this using our CodeKit Circuits simulator. At the moment, this feature is available as part of our Pro and Classroom plans, and I'm going to show you how you can build this from scratch, including both the circuit and the code. So, without further ado, I will stop the simulation and we can start with a blank project. So, firstly, let's go to the circuit section that's over here on the sidebar and click on circuits. You'll need to be signed into your EduKits account with an active subscription for this to show up. Now, we will begin with an Arduino board. You can find the Arduino Uno over here in the left sidebar, along with all these other components. And I can click and drag this over onto the workspace canvas. Okay, so we have our board. And the next thing I'm going to do is add a little mini breadboard, which is where we are going to place our LEDs. Now you can just drag and drop components over here onto the canvas, and then once you've got them there, you can click and drag them to move them about and arrange them in the ways that you'd like. And also, if you're looking for a specific component, you can just use the search. So if I wanted to search up for our LED, then that makes it really easy to find that over here. So I'm going to click and drag our first LED over here onto the canvas, and we will add it to this mini breadboard. So we have one LED in. Now I think we are going to need 5 more. So I can add the next one. That's 3, 4, and then 5. And I was just clicking over there and then dragging it over here. And we have this easy snap feature where you can just drag and drop the LEDs and they will snap to the right spots on the component breadboard. I think we actually needed a 6th one. There we go. Okay, so when you click on an LED, we have this option to pick the color. If you saw the demo at the start, we had different colors, and I'm going to go through this little rainbow here for each of the LEDs so that we have different colors lighting up as we go through the chase effect. Perfect, so we've gone all the way from red straight through to white LEDs. Now I'm going to start connecting the wires here. And I might just move these over here a little bit. Okay, that looks fantastic. The first thing we're going to need to do is connect all the grounds together. All of these LEDs need a positive and a negative connection. And what we'll do is we'll hook all of the negative connections together, and then we will put the positive connections together to the right pins. So if you hover over each of the legs of these LEDs, it tells you which one is positive and negative, which is super helpful. We'll start over here on the left, and we see that this one is negative. Now all of this column of the breadboard, all of those connections, all those terminals are actually joined together. So if we plug this particular, if we connect this particular input of the breadboard to ground, that is actually going to link up the LED because it is in the same column. Next, we want to connect this negative to this negative, to this negative, to this negative, to this negative, and so on. We can just do that. I'll zoom in over here so you got a closer look. We can just do that by clicking over here and joining it to this column of the breadboard. So this column is all connected as well to itself. And so that means this negative is now joined through this wire to this negative. We can do the same thing to join this negative to this negative. And you can see the pattern is basically we just kind of crisscross weave like this, and that is connecting our negatives. So now we have everything we need to connected to ground. Next, I'm going to connect each of these LEDs, the positive pins, over to a specific digital output over here. So we're going to start over with 13 for the red, and then we're going to move over for the orange, the yellow, the green, the blue, and the white. And we're going to keep these wires super organized. So I'll start over here. Remember, this column is connected to the red positive. I'm going to click over, and then I can just click again to add another point to the wire, which allows me to create these shapes, and I can click over there to kind of rearrange these. And then using the drop down, I'm going to select the red wire. And this helps us figure out where things are connected. So I'll match the wire color to the LED that I'm connecting it to. Next, we can do the orange LED. Whoops. Next, we can do the orange LED. And I would change that to orange. We can do the yellow LED. I will change this to yellow color. Green one. This is green. There we go. And then the blue LED. To finish this off, I will connect the white LED to pin number 8. Whoops. Okay, there we go. We're all set on the wiring front. Now, to do a quick test, we can just go through and turn these LEDs on. I will do that by going under the block editor. We have a blank project here. Then I can just grab the inputs and outputs, and we start it at, I just do this over here in the start. We start it at pin 8. We can go 9, duplicate, 10, whoops, 10, duplicate, 11, duplicate, 12, duplicate, and 13. So these blocks, basically, they set from the input and output category, they just set each of the items connected to these pins to high, in which means on. So we've gone from 8, 9, 10, 11, 12, and 13. That will do all of our LEDs. So if I go back to circuits, and then I hit the run code button, that is going to compile the code. And as you can see, all of our LEDs are activated. So our wiring is working okay. And now we can work on our code to get the chase effect working. Let's head back to the block editor. So a trick that we're going to be needing to use to get our chase effect working is a special kind of loop. Over here, we have 6 different blocks for setting the LEDs to high, for turning them on, basically. And that's a lot of blocks, and this program is going to be getting quite complicated if we want to turn only one LED on at a time. We're going to be needing to do that, 6 times overall, and honestly, it just gets very repetitive. So we're going to be using a loop to do this, which means we can write our code once and have it run for each of the LEDs. So I've got rid of everything except just a single set pin block. And I'm going to go over to the loop section and grab one of these count with I blocks. And I will place it over here and then put my set pin block within that. So what this does is it will create a special counter. And in this case, it's called I. I will rename this and call it LED. So it gives us a special counter, now it's called LED, that's going to count from 1 to 10, and it will go up by 1 each time this loop runs. And to use this counter, I can right-click on the loop and use this create get LED, and then I will plug this into the pin input of our set pin block. So what does this do? Well, now we have this counter, and it's counting up by 1 every time, and it starts at 1. And as is, this will set pin 1 to high, because that's what the counter starts at. And then once we loop back around, it'll increase by 1, so this becomes set pin 2 to high. So this means we can run this set pin block for every number that our counter goes through. And in our case, we would like to go from 8 all the way to 13, and we will go by 1. So this means that we don't have to write all those blocks anymore. We can just use this one block and repeat it using our special counter loop. So going back over to our circuits, I will compile this code and run it, and you can see that even though we didn't explicitly create blocks for each of those LEDs to turn them on, our counter loop went straight through and turned them all on for us. That is fantastic. So the next thing we want to do to finalize this is to bring this loop over to the forever block, because we would like our chase effect to happen over and over again. And instead of just turning the LED on, we should turn it off. So I will duplicate that block and turn it to low. And we're basically creating a blink program here. We're blinking one LED, then with that counter, we're blinking another LED, and we're moving through them. And then once we've done all of them, we're going to repeat again. Under control, we can grab the delay we need. And I'm going to use this milliseconds block and right-click and duplicate that to create a second one. And this will create our delay after turning the LED on, and then after turning it off before we move to the next one. Because there are quite a number of LEDs, you probably only want a small delay. So I will pick a delay of 100 milliseconds. And this is going to mean it's only a very short time before we move from one LED to the next. Going back to the circuits mode and running that code, you can see that we are now starting at the LED at pin number 8 and going all the way up to pin number 13 with our blinking behavior. Now, if we want to go the other way, like we had in the original demo, I can start at 13 and then go to pin number 8. So now if I run the code, it will go in reverse direction, which starts at 13 and goes down to pin number 8. So I hope this video helped you understand how to build simple circuits within CodeKit circuits and to build programs to go along with them. I hope you learned something, and if you would like to see more content like this, don't forget to subscribe to our channel and check out some of our other videos.